Hello. Today I want to show you how to instantiate objects in code. So when I say instantiate objects, what I'm talking about is creating a new instance of a symbol that's in our library. Now in Flash normally we do that by just going to the library and dragging out a symbol from the library. That creates an instance inside of the Flash Professional program. And I'm going to show you how to do it in code at runtime. So first I'm going to choose the shape tool and I'll pick a color. I'm going to turn off stroke and just draw the shape to the canvas. And I'm going to hit F8 to turn this into a symbol, and I'll just call the symbol pentagon. I'll delete the instance off the stage, and you can see when we run it that there's nothing on the stage. So what I'm going to do is I'm going to write some code to create this at runtime. First thing I have to do is I have to go into the library and I have to give this symbol a class name. So right click on the symbol and go to properties, and under the advanced category we're going to turn on export for ActionScript. Now we're going to type in a name for the class of this symbol. The class name should be capitalized and not have any spaces in it. So I'm going to call it Pentagon with a capital P. Now in my code, I can simply write new Pentagon, and that will create a new instance of that symbol. Now when I run my script, I don't actually see the new Pentagon because it hasn't been added to the display tree. So I'm going to modify my code a little bit. I'm going to put that new Pentagon inside a variable, and I'll call that variable P. And then we can pass that pentagon into the add child function. Add child will go ahead and add that instance of the symbol to the display tree so that we can see it. When we instantiate a new object, its X and Y values by default are both 0. So if we were to drop a pentagon onto our stage and set its X and Y to 0, notice that it defaults to the upper left-hand corner. So we can of course override this. We can say p.x equals 275 and p.y equals 200, and this will place the pentagon in the center of the screen, since the screen is 550 pixels wide by 400 pixels tall. If I want to create lots of pentagons, I can simply create a for loop that runs 10 times. I'll put all the code in that for loop to create the pentagon. You'll notice here the for loop runs 10 times, and when we compile it, all 10 pentagons are stacked on top of each other. So what we're going to do is set the X and Y property for each pentagon to a random number. So I'm going to use math.random. It's a function that's going to give me a number between 0 and 1. And if I want a number between 0 and 550, all I have to do is multiply math.random by 550. Similarly, we're going to say p.y equals math.random times 400. This is going to result in the y value being some number between 0 and 400. Let's do the same thing for scale. There is a scale property, but it doesn't do anything for the movie clip class. So we want to use scale x and scale y. Now if we want the object to scale proportionally, we want to set scale y and scale x so that they're always the same number. Now instead of 0.1 for the scale x, let's go ahead and use a random number again. Let's say I want a random number between 0.1 and 0.6. That's a range of 0.5 with a minimum of 0.1. And maybe I want to reduce that range down a little bit. Maybe let's say 0.25. Now that's going to be a number between 0.25 to 0.35. We can also generate a random rotation value. So p.rotation equals math.random times 360, and that'll give me a number between 0 and 360 degrees. Let's go ahead and make it so that not all of these pentagons are the same color. Let's double click on the symbol in the library, and once we're inside of it, find the timeline and let's add some new keyframes. I'm using the F6 shortcut to create new frames on the timeline. And on each of these new keyframes, I will just change the color a little bit. I'm going to put some code inside of this object. So I'll create a layer for code. But before I do that, let's go ahead and run the project, and you'll see that each instance of this object is playing through its timeline and showing us each of those colors. So what we can do is in our code, we can tell it to go to a specific frame. So let's say go to and stop on frame 3, and you'll notice that all the symbols are now the same color. They're not animating. But instead of sending each symbol to frame 3, let's generate a random frame to go to. So I'm going to create a variable called frame that can store an integer, and I'll use math.random to generate a random number. Math.random generates a number between 0 and 1. It is a floating number, and if I multiply that by 5, we'll get a number between 0 and 5, which will also be a floating number. Since frame is an integer, I have to cast this from a floating point number to an int. And once we do a cast, that'll actually round down the numbers. So in this case, it would be a number between 0 and 4. So I'm just going to go ahead and add 1 to it so that I get a number between 1 and 5. If I take that frame variable and I pass it into go to and stop, we now have a movie clip that will start on a random frame. All right, let's add a little bit more to this symbol. I'm going to add a new event listener, and this event listener is going to run every time the screen is erased and refreshed to redraw. Now, since our application here runs at 24 frames per second, this event listener is actually going to execute 24 times every second. This can essentially give us a game loop, and you can create your own video games inside of Flash. What I'm going to show you how to do, though, is how to make these particles spin. So every time we call the handle frame function, let's just go ahead and add 10 degrees to our rotation value. So now each of these is spinning 10 degrees each update, and since there are 24 updates per second, they are spinning at 240 degrees per second. We can also have them move by adjusting their X or Y value. So if I want them to fall like gravity, we can add 1 to Y. Now that's kind of slow, so let's go ahead and increase that from 1 all the way up to 10. You'll notice that it doesn't really feel like gravity since there's no downward acceleration. So if we want the object to accelerate down, we actually can't increase it by a constant literal value. So that tells us we need a variable. I'm going to create a variable called speed y, and I'll give it a default starting value of 0. Each time our event handler is called, we'll increase the value of speed y, and then we'll increase y by the value of speed y. This will create the effect of gravity. Back in our main timeline, let's also add an event listener. I'm going to use the same interframe event listener so that this event handler function runs 24 times a second. Again, we can use this to create game loops. Here what I'm going to do is I'm going to use it so that every frame I'm continually generating new pentagons. So let's just go ahead and copy and paste the code for generating a new pentagon. And I'll just delete my for loop. And now, every frame, we're constantly making one new pentagon. So that's 24 pentagons per second. However, they're starting at completely random places, and I want them to maybe start out wherever my mouse is. So I'll set the X value of the pentagon to mouse X, and I'll set the Y value to mouse Y. Now, as I move my mouse, the new pentagon each frame spawns in wherever the mouse is. I want these pentagons to maybe look like they're bursting. So I'm going to give them a speed X as well as a speed Y. So I'll create a speed X variable. Its data type is number, and I'll default it to 0. And each time through this object's handle frame event handler, we're just going to add to X the speed X value. Now we'll just test this real quick. Nothing has really changed. So let's go ahead and give speed X a value. Let's say math.random times 20, maybe we'll go times 40, and then minus 20. This is going to give us a number between negative 20 and positive 20. So the particles, as they spawn, they are bursting either outward to the left or to the right. Let's also give the speed y a random value. Let's say math.random times 20 minus 20. This gives us a random range of numbers between -20 and 0, so that the particles start out their life by moving upwards on the screen. I think this is a pretty cool effect. Well, that's everything I wanted to show you in a nutshell. There's all kinds of other things you can explore here in Flash. I would encourage you, if you have some time, see if you can make an interactive game. Maybe start by spawning objects at random and then see if the user can click on those objects to get points, kind of like a fly swatter or a whack-a-mole. In any case, I hope you learned something. Good luck. Go create something cool.